Welcome back to our math video series. Today we begin trig functions and trigonometry. We'll be looking at trig ratios, measurements for angles. We'll also look at trig function values, and finally cofunctions and reciprocal identities. To begin with, a few things that we should know about triangles already. One thing is that we'll be looking strictly at right triangles in this section. Now, if we wanted to label this triangle, and I say wanted to put the side opposite in, I go in and I'm not sure where to put that, because to label any triangle, recall that you need to first fix an angle somewhere. So if I fix this as my angle, now I can say this is my side opposite. Hypotenuse we know is always the longest side, and if this is my angle, this is the side right beside, it'll be called my side adjacent. If I switched my angle to up here, then my side adjacent would follow it and would be up there, making my side opposite down here. So make sure when you're dealing with any of the triangles that you fix your angle first and then plot your opposite versus hypotenuse. Also, we can label the sides of the angles of our triangle. Typically we say angle C is the right angle, making side C our hypotenuse, and then the other sides, it wouldn't matter which side we put them on, A and B. Also recall that Pythagoras is a useful tool for us to use. If I know two sides of a right triangle, I can solve for the third using Pythagoras. Now, one of the things you've also seen in the past is that there's certain ratios or relationships between the sides of a right triangle. The sine ratio, for example, relates the opposite side to the hypotenuse. So if I'm looking, say, at this angle here, let's go to this one. If I'm looking at that angle there, the sine ratio relates this opposite side to the hypotenuse. Whereas the cosine, if I was looking at the cosine of theta, it would relate the adjacent side to the hypotenuse. And finally, the tangent relates the opposite side to the adjacent side. SOHCAHTOA is a nice way of remembering those. Sine is opposite over hypotenuse, cos is etc. So if you want to learn that, that'll help you remember the ratios. We can also look at reciprocal ratios. So the reciprocal ratio, rather than looking at the opposite over hypotenuse, I could look at the hypotenuse over opposite. We call that the cosecant ratio. Similarly, if I have cosine as adjacent over hypotenuse, the reciprocal of that is called secant. Tangent, its reciprocal is cotan, or adjacent over hypotenuse. Over here, I can also write those relationships, that the sine is equal to 1 over cosecant, or I could write cosecant is equal to 1 over sine. Like this one here, cosine is 1 over secant. I could write that as secant theta is equal to 1 over cos. And I could do the same thing with tangent. Okay, so if we needed to solve for any angle in a right triangle, here's some steps that we could do. First off is to mark the angle that we want to use. So say in this question I was looking for angle B. So this is the angle that I'm looking for. I mark that angle, and then, given the information that is in the question, I determine which ratio I should use. So if angle B is given, then this side over here would be my opposite side, and this side, of course, would be my hypotenuse. So I look for a ratio that relates the opposite side and the hypotenuse. Right up there, sine. Let's write that down. Sine theta is equal to the opposite side over the hypotenuse. Now we substitute in our numbers. Okay, so sine, angle, this is what I'm looking for. It's called B, so we'll call it sine B, is equal to the opposite side, which is 6, over the hypotenuse side, which is 8. So here I've got an equation now. I've got an equation in which I need to solve for B. Well, to solve for B, sine is in the way. I have to get rid of that sine. And similarly to if I have an equation like this where I need to solve for x, I can square root both sides. If I have a sine ratio, I can do a similar thing. I won't square root, but I'll do whatever the opposite of sine is. And that happens to be arc sine. So I can arc sine this, and you probably won't see this in the book anywhere, but I can also arc sine this. This side you will see in the book. So I'm going to arc sine the sine of b, and I'm going to arc sine 6 over 8. On the left side, the sine and the arc sine cancel each other out, leaving me with just b. That's how I can solve for just the angle. And then I'll take the arc sine, I'm just doing this on my calculator, of 6 over 8. That gives me approximately 48.6 degrees. So this angle here will be 48.6 degrees. If I wanted to now, I could also solve for this side. This side, adding these two together and subtracting from 180 should give me about 41.4 degrees. I could also solve for this other side. Since I know two of the sides, I could use Pythagoras, or I could use one of these other ratios and solve for that side now that I know all of the angles. So that's how I can solve for an angle in a right triangle. If I need to solve for a side, I must be given one of the angles in the right triangle. Just quickly, I can write this one as 52 degrees because they have to add up to 180. Similarly, in this question, I need to first mark my angle. So that gives me which sides are opposite and which sides are adjacent. Let's use this angle here, the one that was given to us. So angle A is 38, and I'm given the hypotenuse side. So the ratios that are in would be any ones that have a hypotenuse, these two. In the question, I didn't write which side I'm looking for. Let's go for this side. Let's look for side B. That's the one we want to know. So given that that is my side adjacent, then I have adjacent hypotenuse. I'll be using the cosine ratio. So cosine of any angle is equal to the adjacent side over the hypotenuse. Notice I write that down every time. So the cosine of 38 degrees is equal to the adjacent side, which we don't know, but we've called side B, over the hypotenuse, which was 15. To solve then for B, I'm dividing this side by 15, so I'll multiply this side by 15, multiply that side by 15, leaving me with a B, which is what I'm looking for, on the right hand side. And then I simply go 15 times the cos of 38 degrees, and that gives me approximately 11.8 units, centimeters, meters, whatever the question might have. So that's how I can solve for a side. Mark my angle, determine which of those three ratios I should use, plug in my numbers, and then solve for the side. Now sometimes I have to deal with reciprocal ratios. Since those aren't on my calculator, I need some strategies to deal with how I would do these. Now, one of the things I know is that tan is equal to 1 over cot, or cotan is equal to 1 over tan theta. So if I look here, I have cotan of 23. I could just plug that in there. Cotan of 23 is equal to 1 over the tan of 23. Just following this reciprocal ratio right there. So on my calculator, I simply go 1 divided by the tan of 23. I get about 2.36. So the value of this, cot 23, is 2.36. Which means that if I were to draw the triangle, and say this was the 23 degree angle right here, that the relationship between cotan is the opposite of tan. So the relationship between the adjacent side and the opposite side is 2.36 to 1. In other words, this side is about 2.3 times as large as this side. Okay, so that's how I can deal with the reciprocal ratios if I'm given the angle. How about if I'm given the ratio and I need to find the angle? This is a simple trick that I've used to figure this one out. Cosecant's not on my calculator, but the primary ratio is. So what I like to do is just convert this, just change this one directly to sine theta. That's its reciprocal ratio. And so on this step here, all I'm doing is finding the reciprocal of cosecant. But if I find the reciprocal of this side, I also have to apply that to this side. The reciprocal of that would be 1 over 2.94. Now I have a case where I have my primary ratio. Now I can solve. And we saw here a slide or two ago that to solve this, I can take the arc sine of this side as long as I take the arc sine. I should have done this on another line. Arc sine of that side. So if I take the second sine or arc sine of 1 divided by 2.9400, I come up with approximately 19.9 degrees. So the angle then that provides this ratio is about 19.9 degrees. Again, let me draw that. 19.9 might be about like that. That would be a good hill to climb on a bike. And so they're saying sine ratio is 1 over that. So the opposite side to the hypotenuse side is 1 over 2.94. So if the opposite side is 1, the hypotenuse is 2.94. So in drawing that angle, yeah, that in looking at it, that makes pretty good sense. The smaller this angle is, the smaller this ratio gets to be. It might be 1 over 5 or 1 over 6, depending on how small that ratio gets. Okay, now let's turn our attention to looking for exact values of all ratios. Notice in this case here, they're looking just for the ratios. They're not looking for the angle beta. They're just looking for the ratios. If they've already given us one of the ratios, I should be able to find all of the rest of them. The first thing I do is make sure I determine what 2 of the sides are, and then figure out the third side by using Pythagoras. Knowing all 3 sides of the right triangle, then I could determine what all the ratios are. So let's explore what this means. Secant beta is equal to root 17. Well, secant I know is the reciprocal of cosine. So if I take the reciprocal of this, I must take the reciprocal of that. That's 1 over root 17. But I know that the cosine ratio relates the adjacent side to the hypotenuse. So in terms of ratios, the adjacent side must be 1 if the hypotenuse is root 17. Knowing what my adjacent and hypotenuse sides are then, or the ratios anyway, I can determine the third side just using Pythagoras. So Pythagoras says that c squared is equal to a squared plus b squared. I could rewrite that as hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. It's the same thing. So we've determined that the hypotenuse is root 17, okay, squared, is equal to the adjacent side is 1 squared plus the opposite side squared. In solving for this equation, root 17 squared will just be 17. 1 squared will just be 1 plus the opposite side squared. Subtracting 1 from both sides leaves 16 is equal to the opposite side squared. Square rooting both sides turns out that the opposite side is 4. So if I'm drawing a triangle, and this may not be drawn to really good scale, but if this were the angle in question, say it was that angle right there, the hypotenuse is root 17, the adjacent side is 1, and the opposite side is 4. So now I know all 3 sides of that triangle. I can give them all the ratios they want. I've already given them 2. In the question it gave them the secant ratio and the cosine ratio. If they want the sine ratio, we can do that. I know that the sine ratio is opposite over hypotenuse. Well, in this triangle the opposite side is 4 and the hypotenuse is root 17. Quickly I can give them the cosecant ratio because I know that's the reciprocal of sine. That'll be root 17 over 4. If they want the tangent ratio, I'm up for that. Tangent is opposite over adjacent, so that would be 4 over 1. And finally, the cotan ratio would be the reciprocal of tan, or 1 over 4. So if in a question they ask me to find the exact values of all ratios, and they give me one ratio, find out what that one ratio tells me. And in this case here, converting it to reciprocal of both sides, I found that the cosine ratio was 1 over root 17, giving me the adjacent side and the hypotenuse side. Using Pythagoras, I could determine what the opposite side was. Once I knew all three sides, then I could give out all of the ratios. And these are the exact values when they have root signs in them. Now, sometimes or often we have triangles that have special angles. And these are some nice triangles to memorize, because we're always finding that we have 45-degree angles, or we're having 30-degree angles and 60-degree angles. So these are nice ratios to memorize. So if I have a 45-degree angle, for example, we'll just use this angle here. If I have this 45-degree angle, then I can look at, say, the cosine ratio. Cosine of 45 degrees would be the adjacent side over the hypotenuse. Oh, these are wrong. These are wrong. Let me delete that. I'm glad I looked at that. Copy, paste. Whew. Don't memorize that one that I just had in there. Memorize this one. Okay, so the cosine ratio is the adjacent side, which is 1, over the hypotenuse, which is root 2. If I look for the sine ratio of 45 degrees, the sine is opposite, which is 1 over root 2. It's the same. And since it's a 45-degree angle, these sides better be the same, so the ratio should be the same too. And finally, the tangent ratio of 45 degrees will be the opposite side over the adjacent side, or 1 over 1, or just 1. Similarly, down here with the 30, 60, 90, let's hope I got these ones right. I think so. If I'm looking for the, say, sine ratio of 30 degrees, to get the exact value of the sine of 30 degrees, opposite side over hypotenuse, 1 over 2. If I have the cosine of 30 degrees, it's adjacent over hypotenuse. And if I'm looking for the tangent of 30 degrees, it is the opposite side over the adjacent side. This triangle, since 30 and 60 go together, also will give me what the sine of 60 degrees is. So if I'm looking at this angle here, sine is opposite over adjacent, root 3, or opposite over hypotenuse, root 3 over 2. Cosine of 60 is adjacent over hypotenuse. And tangent of 60 is equal to opposite, root 3 over adjacent 1. Okay, so these special triangles here can give us those ratios. And these 45, 30, and 60 are angles that we'll see popping up quite often. Just one little point about cofunctions. Cofunctions have, they're talking about in sine and cos and those ratios, there's often things that pop up that are the same. Similar to what we saw down here with 30 and 60, notice that the sine of 30 was a half, but the cos of 60 was a half. And so we seem to find angles between sine and cos in particular that pop up all the time. So on your calculator, try what the sine of, say, 80 degrees is, and then find what the cos of 10 degrees is. Notice that these two angles add up to 90 degrees. Or I could say sine of 42 and figure out what the cos of 48 was. And you'll find that these are cofunction angles. In other words, the sine of 42 is going to be the same thing as the cos of 48, because these two angles add up to 90. Okay, last concept in this section is talking about angles in degrees, minutes, and seconds. Here's a picture of the Lethbridge College. In it, here's my office right over in here somewhere. Anyway, the exact direction of the Lethbridge College, looking at Google Maps, is 49 degrees, 39 minutes, 39 seconds north. and 112.8081 degrees west. I've sort of gone in and changed those a little bit, but this would be an angle measurement in degrees, minutes, seconds, and this one would be a decimal degree. And what I want to do is just quickly show you how you can convert from one to the other. So for example, if I have 49 degrees, 39 minutes, and 39 seconds, if I want to take and convert that to decimal degrees, what I do is I start way over on the right hand side. And I take, instead of 39 seconds, I say, well, that's 39/60ths of a minute. And so I figure out what 39 divided by 60 is on my calculator, and it's about 0.65, and I tack that on to the minutes. So it'll be 39.65 minutes. Then again, take this number and divide that by 60. So 49 degrees, and take my 39.65 and divide that by 60, because there's 60 minutes in a degree, or 60 minutes in an hour, you could say. And that comes out to about 0.66, and you tack that onto the 49 degrees. So 49 plus the 0.66 gives me 49.66 degrees. So that would be my decimal degrees, given this as my degree, minutes, and seconds. Similarly, if I wanted to take this degree, decimal degree, and change it to degrees, minutes, seconds. So here's my decimal degree. To convert that into degree, minute, second, I just take this decimal portion and multiply it by 60. So I'm going to take the 0.8081 times that by 60, and that'll give me how many minutes there are. So 0.8081 times 60 gives me 48.486. So 112 degrees and 48.486 minutes. Now take again the decimal portion and times it by 60. So 112 degrees, 48 minutes, and then I'm going to get 0.486 times 60 seconds. Okay, let me do that on my calculator. Times 60, and so this will be 112 degrees, 48 minutes, and 29, there's a decimal there, but I'll leave it off, seconds. There's how you can convert between degree, minutes, seconds, and decimal degrees. So today we've just done a quick little review of right triangle trigonometry. We've looked at the primary and the secondary trig ratios, and we've worked with finding the angle or finding the side. And finally, we've looked at different ways of expressing an angle in either decimal degrees or degrees, minutes, seconds.